I'm figuring this out. I'm right side up again, right? Okay. I got a special request. Michaela was doing a Khan Academy lesson on volume and was a little bit confused. So she mentioned it to me, which is exactly what I want you guys to do. I know there's quite a few of you doing that Khan Academy. And I know that a lot of you are leveling up a lot. Aiden Hirsch got like a Newton Award for leveling up on 400 different objectives, right? Awesome sauce. You don't have to do 400, but hey, keep working, right? Remember, anything you're doing now is going to help you later. So what I would like, though, and Aiden hasn't done this even yet, is when you run into a little bit of trouble, when something's confusing, the Khan video was not completely clear, give me a chance. Let me know. I get practice when I do this, and I'll do a quick little lesson on whatever it is that you are having trouble with. Maybe I can explain it in a way that helps you a little bit better than the Khan Academy video did. But this is what I want. So Michaela was having a little bit of trouble with the Khan Academy volume and wanted a little help. So I want to make a quick little lesson. So let's switch over to where you can see and flip it up right for you. Want to review a tiny bit. When you first started learning how to do lessons and measurement, what you wanted to do is you wanted to measure how long a line was usually, right? How long is it, right? When you measure the length of something, you're getting a length, right? Long and length have a lot of the same letters, right? So that helps me, right? And when you're measuring something, it might be a line like that, and you get that line out, and you get your ruler out, and you say, okay, I want to measure how long this is. So again, not the edge of the ruler, but where the zero is. So that notch there, it looks like that is 10 centimeters long. The line below it, let me see, line it up, looks like 6 centimeters, right? So it's already been labeled for you. You're measuring a length, and then sometimes you wanted to measure how long a line would be if it went all the way around a shape like this, right? This rectangle is 3 centimeters long and 2 centimeters tall. If I want to go all the way around it, that's called the perimeter. I have this 3 plus this 2 plus another 3 and another 2 because I want to go all the way around, right? 3 plus 2 plus 3 plus 2, that's like 5 plus 5. 10 centimeters is the perimeter. And again, I kind of like that the word perimeter has the word meter in it, because what does meter mean? Well, if you have me for science, you know it means measure, right? Good name for our metric system, measure, right? When you got done learning how to measure how long something was, or one-dimensional, 1D, you then learned in 4th or 5th grade, you started getting something called the area of something, right? And the area has 2 dimensions. It has how wide is it and how tall is it. So in this example of this rectangle, I have a rectangle that's 8 units wide and 3 units tall. And when you're getting the area of something, you want to know how many squares it takes to cover it. I like to say visualize how many stickers it would take. You know, if your sticker is 1 centimeter wide and 1 centimeter tall, it's 8 centimeters wide for this rectangle, 3 centimeters tall. How many stickers does it take to cover it? Well, I have 3 rows of 8 or 8 columns of 3. Either way, I have 8 times 3 or 3 times 8. It would take 24 squares to cover that, right? 24 square units. In this case, square centimeters. It has 2 dimensions, or 2D, right? How many squares does it take to cover it? And again, 2D. What's after 2D? 3D, right? And 3D is when we are talking about 3 dimensions. A 3D movie looks like it's coming out of the screen to you, right? It really looks cool. Just like this cube is coming out of the screen to you. Oh, all right. Rectangular prism, right? It has a width, it has a depth, it has a height, right? But 3D, 3 dimensions, and that's what we're talking about when we get volume, right? Remember when we did length, we just had that 1 dimension, how long it is. When we did area, we had square units. For volume, we're going to have cubes. How many cubes does it take to make this? right? Well, this is called a rectangular prism, right? It is a rectangle that has straight sides, right? The rectangle was 2 dimensions, right? In this case, 4 rows of 2 or 2 rows of 4. So to do that top layer, it took 8 cubes. But the third dimension is how many layers of 8, right? How many layers of a rectangle that is 2 by 4? Well, if I turn it on side, you can see it is 2 layers tall. I have 2 layers of 8. So how many cubes, how many cubic units does it take to make this? Well, 2 layers of 8, 16. This is how we build buildings in California, right? We're worried about earthquakes, but it's a pretty big state. We have lots of room most places, right? But when you get to like Manhattan or even downtown San Francisco at this point, real estate gets real expensive. You don't want to go across the bridge and build a building. You want to build it right there, but you want it to have a lot of people be able to go into it. You build them upright, right? We worry about earthquakes. There aren't as many buildings upright as there are like Manhattan, right? New York City, right? But in that case, you have a small, what they call footprint of 2 by 2, that's square. How many stories tall is it? 4 stories tall on this one, right? So that's 4 layers of 4. What's that? That's also 16, right? So California, 2 by 4, 16, right? I mean, sorry, that's 8. And then 2 layers of 8 makes 16. Manhattan, New York City, 2 by 2, that's 4, but 4 stories tall, twice as tall. That's also going to get 16. It's the same, all right? 2 times 2 times 4 is the same as 4 times 2 times 2. Here we go. Here is a drawing of another one. This rectangular prism is 4 by 4, and that's why there's a red 16 in there, right? 4 layers of 4, 4 rows of 4. It took 16 cubes to make that top layer. It's 2 layers tall, so I have 16 times 2, 32 cubic units. And remember, the abbreviation for cubic units is to the third power, and we remember that because it's 3D, right? So one of the things you'll find out when you do volume, if you have what's called a prism, and again, that's a shape that has the same shape on the bottom as on the top, right? The bottom of this is 2 by 2. It's 4. It's a square that is 4 square units. The top is 2 by 2. It's a square. It's also 4 units. And it has straight sides. The trick is you can get the area of the top or bottom. They call it the base with a capital B, and multiply it by how many layers, and you get the volume. That works not just with these rectangular prisms, but with any prism, right? You can have a triangular prism. If this triangle here is the same as this triangle here, then you can get the area of that triangle and multiply by how tall is it, and you get the volume of that triangular prism. Same thing with this rectangular prism. If this rectangle on top is the same as this rectangle on the bottom, you can get the area of that rectangle, multiply by how tall is it, and you get the volume. It even works with something like this. With what's the shape of this? It is called a cylinder, right? And if this circle on top is the same as this circle on the bottom, it would have straight sides. You can get the area of that circle and multiply by how tall is it, and you get a volume of a cylinder. It's pretty cool. It would work with any shape that had the same shape as on the top as on the bottom and straight sides. Remember, straight sides, we're talking about 90-degree angles, straight up and down, straight up and down, straight up and down, right? Anyway, hopefully this helps you when you are doing some volume problems. I will get a couple Pizzazz worksheets coming your way, and you can review this before you do the Pizzazz worksheets, and then maybe I'll do another video showing you how to solve a specific one. Anyway, I'm going to go ahead and stop this now.